We're still in 3.1c, part 2. We're looking at solving a system of 3 linear equations in 3 variables. We have our steps. First, I want to pick a pair of equations and eliminate a variable. Whichever variable is most convenient. Then I'm going to pick another pair of equations and eliminate the same variable as we did in step 1. So since I've eliminated one variable out of my 3, I should now be a system in 2 variables. So if we're a system in 2 variables, we can use either substitution or elimination to solve the system in 2 variables, just like we did up here in the previous example. Once I solve that system, I will know 2 of the variables, whether it's x and y or x and z, etc. Once I know 2 of the variables, I can substitute those 2 variables in to one of the originals to get the third variable to complete the ordered triple. Those are going to be our steps. So let's take a look at example 8. I apologize, I had to rewrite this one. I made a mistake with a negative and I needed to fix it. So in example 8, I want to solve this system. Now I can eliminate any variable first, so I'm going to look at all 3 of them. So for x's, if I chose this pair, I could use 2 for x. If I chose this pair, I could use 1 and 3, I could use 3. If I chose y, I could use 3 and 1 with 3. Looking at these kind of multiples here, or 5 and 1, I could use 5. 5 and 1 or 3 and 1, any of these would work. Let's stick to the smallest. Let's use the 2 and the 3 so we don't need to get the 5s involved here. Okay. So in our first step, we'll eliminate x in the top 2 equations. In our second step, we'll eliminate x in the bottom 2 equations. So let's just write down what we're going to do. So step 1, we'll eliminate x. Now, I already have a 2x in the top equation. I need to create a 2x in the bottom equation. So we want to multiply this one by negative 2. So I'm going to take negative 2 times that entire equation. So I have opposites. Okay. So negative 2 times x minus 5, y plus 5z equals 3. And if I distribute that all the way across, that gives me negative 2x plus 10y minus 10z equals negative 6. I can just copy down the top equation now. The top equation is 2x minus 3y plus z equals 2. And then we're going to add the 2 equations together to eliminate the x. Negative 2x plus 2x is 0. 10y minus 3y is 7y. Negative 10z plus z is negative 9z equals negative 6 plus 2 is negative 4. Okay. In step 2, we're going to eliminate the same variable again. So we're going to eliminate x, but now I have to use 2 different equations. I could choose top and bottom, but then I'd have to use a least common multiple of 6. It's just more work. So I'm going to choose middle and bottom, so I can use a least common multiple of 3, and I already have a 3x in the bottom equation. So all I need to do to start is multiply a negative 3 times that middle equation to create one positive 3 and one negative 3. Okay, so this will give us negative 3x plus 15y minus 15z equals negative 9. And I keep the bottom equation the same since it already had a positive 3x. Plus y minus 3z equals 5. We add those up. We selected the multiple so that the x's would eliminate. We have 15y plus y is 16y. Negative 15z minus 3z is negative 18z. And then I have equals a negative 4. Okay. So we are going to now, in step 3, take these 2 equations and try to eliminate a variable. If I'm looking at these variables, 7 and 16 don't seem very compatible. But 9 and 18 are very nicely compatible. I can make them both 18s if I multiply the top equation here by -2. That will give me one positive and one negative 18. Right. So let's do that. That'll be -14y plus 18y equals 8. Let's keep this one the same so that we have the -18. So it's going to be 16y minus 18y equals -4. We're going to add those up. So I'm using the two variable equations together to get rid of whatever's most convenient. I could do 16 and 7, but I have to multiply out by a lot more. 8 and 19 have at least come out with 18, a lot easier to work with in this case. Okay? So we're going to add these up. -14y plus 16y is positive 2y. The 2y terms eliminate, they add to 0, equals 8 minus 4 is 4. And I can divide by 2 to get the first y value, the first value, which is the y, equals 2. Alright, so that's our first value, y equals 2. Now I'm not finished with step 3. I actually get to use this y equals 2 and plug it into my choice of the two variable equations. I like the 7 and the 9 better than the 16 and 18, so I'm going to choose this one. So it's going to be 7 times y is 2, minus 9 times z equals -4. So 14 minus 9z equals -4. Let's see if we subtract 14 from both sides. -9z is going to be equal to -18. And divide by -9. Z is going to equal positive 2. So I have the second of our variables. Then step 4 was taking the two variables that I know and going back into one of the original equations. We could choose which one we wanted, doesn't matter. I'm looking for x this time, so how about I choose the middle equation because it has the x value by itself. Okay? So in step 4, I am going to say x minus 5 times y is 2, plus 5 times z is 2, equals 3. That's x minus 10 plus 10 equals 3. Those two 10s add to 0, so x equals 3. So I have our third value. Remember that our solution should be an ordered triple. So the x value, 3, comma the y value, 2, comma the z value, 2. So that's our solution. 3, comma 2, comma 2. In example 9, we're going to get a chance to try again. Here's another linear system and 3 variables. Now this time, each equation just has 2 variables. That's okay. So I'm going to have to work with 2 equations to get rid of a variable that one of the other equations doesn't have. So let me restate that. Notice that I have just x and y in the top equation. If I could use the bottom 2 equations to get rid of z, then I would have another equation in x and y that I could use. It's going to actually save me a step. Or vice versa, I could have x and z right here. I could use the top 2 equations to get rid of y. I think that's actually the choice I'm going to make because I already have a negative y here and a positive y here, so it would be quite convenient to eliminate y right away. So in step 1, let's eliminate y. Okay, so with the top 2 equations, let's space them out a little bit. 2x minus y, plus there aren't any z, equals -8. And then y plus 3z equals 22. I'm going to add these down, and when I do, I'm going to get 2x plus no x is 2x, no y's, plus 3z, no more z to add on, equals, and then 22 plus -8 is 14. So I have an equation that is in just x and z, and I have another equation right here that's in just x and z. So I get to use those two equations together. I go right to step 3 without having to do step 2, using these two equations together. So step 3, let's see, we want to get rid of x or z. I would do z because I already have a negative here and a positive here. I don't like messing with negatives. It can cause more error. So let's do 3 times that equation. 3 times x is 3x minus 3 times z equals 3 times negative 8 is negative 24. And we will leave our 2x plus 3z alone equal 14. Add those up. The 3 z's should eliminate. 3 plus 2 is 5x equals negative 24 plus 14 is negative 10. Divide both sides by 5 and we'll get an x value of negative 2. That's our first value that we have solved for. Now we should be able to find the rest by plugging this x value into an equation that is in 2 variables that contains x. Any equation in 2 variables that contains x. So for example, if I plug that x value into the bottom equation, I can get the z, or I could get the z by plugging it into this equation. I choose the one with the smaller numbers. So let's do x. Oops, I almost wrote x, but I know x. X is negative 2 minus z equals negative 8. So if I add 2 to both sides, negative z is negative 6. So divide by negative 1. Z is going to be positive 6. Now, I also could find y knowing x because I have an equation that just has x and y. Or, now that I know z, I could use the z to find y. Doesn't matter which one I use, just need to find y. I'm going to use x. This is 2 times negative 2 minus y equals negative 8. So that's negative 4 minus y equals negative 8. Add 4. Negative y equals negative 4. And divide by negative 1. That gives us a y value of 4. So our solution should be the ordered triple. Negative 2 for x, comma 4 for y, comma 6 for z.